Welcome in the 7th section, that is the last one section of our course. In this section, we did a troubleshooting of Apache Spark engine in the context of deep learning neural network algorithms and in the context of deep learning 4J that leverages Spark. So if you have a problem with deep learning 4J performance, you can apply those techniques to debug and troubleshoot your programs. So at the beginning, we will see a monitoring of models using Spark UI. Next, we'll see how to speed up computations by employing caching. In the first video, we'll be partitioning deep learning data into number of workers, and also we'll see what partitioning algorithms, schemes are available on the Apache Spark, and we'll contradict it with the first video of 6th section when we created our own partitioner. Finally, we'll be tweaking Spark workers configuration, so we will see what important parameters could be tuned and changed to speed up your Spark program execution. And this is a first video in which we'll be doing a monitoring of models using Spark UI. So at the beginning, we'll start some Spark flow that executes some computations. Next, we'll open a Spark UI and we'll try to understand what is happening inside of our flow. So we'll be doing monitoring flow via Spark UI. So we are given a simple algorithm. So let's say that we are using QSUM partitioner while join. So we are joining two datasets, transactions and persons. So this is not important how this is done, but we are just joining two transactions and persons partitioners. So we are leveraging that join operator and we are sleeping for a really long time. This sleep is needed to not finish our test prematurely because we need to look into Spark UI to see what is happening. So let's start this test and then we will open a Spark UI to see what is happening in our execution environment. So Spark is starting and it should start the Spark UI on a specific port. We can see that if you go to the localhost 4040, you will see your execution job. So we can see here that we have a collect at Spark UI and this is a line 22. So let's go to this line. We can see that this is the line that is executed. So join collect to list that triggers actual collection of data. If you will go to the specific job, you can see steps in that process. So you can see that make RDD was the first step and it was really fast. So it takes 0.1 second. But also then we have a make RDD on line 12 and we can see that it took 80 milliseconds and finally we have a collect that took 59 milliseconds and we can see that every task has two subtasks and both succeeded. Also you can see how much data was read and write. So in the step 0 and 1 the 482 bytes were loaded and 266 and so on. So on production you can debug if, for example, if you will have a task that process too much data, it could be suspicious. Also, we can go into specific line and then we have a detailed things here. So for example, we can see that we see duration of our processing. We can see that our test pass in underneath. So we have a duration of our processing. We have a percentiles and also we have tasks. Task is very important because it tells us how much partitions were executed. So we can see here that we have two partitions that were executed independently and both of them took similar amount of time. We can also open DAG visualization, that is a direct acyclic graph, and we can see that it consists only from the one step. We have some additional metrics and event timeline. So we can see that, for example, beginning was task deserialization time, then we have computation time, actual time of processing, we have a write, and then next step took the same things. So first start from deserialization, then computing time, and then shuffle write time. So if you have a problem, you can go to the UI and debug it from that.